Hello guys, how's it going? Hello people from all over the world. Now we're gonna make our last stream of today, because later we need to make some videos, right? Today we're gonna jump into probably the last chapter of Introduction to Embeddings with OpenAI API. This is my screen. I'm just gonna check that the audio is properly is good. So now we're gonna do this. Here we already started with the solution. The only thing is that we closed the session because our system wasn't like running this code. So let's so we need to fill this here. Then the title should be Netflix titles, and this is the OpenAI embedding function. This is the embedding function. Implying collections is gonna give me the collections. Here, this is already imported, but in our case, we're gonna ask Cloud to autocomplete a place for this file. Complete the missing imports. Now let's run this here. So it did good, I think. Now let's submit the answer. It failed. Client has not attributed collections. So let's explain the error. Okay, so the correct one is list collections. Yeah, and this is supposed to be OpenAI embeddings. And yes, let's do that. And here I'm supposed to pass the API token. So first of all, here is list collections, and now in the OpenAI client, so let's do now looks like now modularize the because here I'm doing this create collection. So let's better create now a model that does this. So now modularize the creation of a collection in a similar way we do for the OpenAI client. So what I want to do is now create another file that is similar to this OpenAI client, but it's can be something like create collection. So I don't need to state the OpenAI token here, you know. Okay, estimate embedding costs with tick token. Okay, import system include this, another configure, load down, it gets the key, represent client create collection. I need to define only the name and the model name. So yeah, so you do yes, and in here now instead of doing this, we can just import that from the Now it's gonna make the import here. 1 second. So yeah, from Chroma client, import client, and create collection. And yes, that's what I wanted to achieve. So in this case, when I do this Chroma client create collection, if I don't specify the model name, I'll use this embedding. So that's good. Okay, that's good. And now I'm also gonna run this now and git bash. Okay, here this will be embeddings, and this will be Python, and here is the 15. And this will create the embeddings in it will create this. Okay, can you explain me where is this new database going to be saved? As far as I understand, it's going to be done locally. So it's going to create in this same folder, it's going to create a Chroma directory. A Chroma SQLite file. That's a folder per collection the data across. Okay, I get it. So if I run this, so I should do pip install minus user chroma db. So now I'm installing this library here. Oh yeah. Yes, please add that to the git ignore. So we don't commit the database into the GitHub repo. Okay, so let's go into the next while it's installing. Estimating embedding cost with tick token. So now we're gonna use this model. Taxonomy model. Very largest total tokens is so I should say for each document in document I should do enc, I assume encode, and it's gonna total tokens is here. Cost is gonna be total tokens times cost per 1,000 tokens over 1,000. But in here it should be the length somewhere like this. But in here I need to sum up all of the. So let's take a hint. Encode. So here should be the length of encode. So it's gonna give me the total length, and then here it should be the sum. Yeah. So for each document, I'm encoding the document and getting the length of the number of the arrays, and then I'm summing all of the the length of each array, and I'm getting the total number of tokens, and then I calculate it like this. Okay, I guess this should be alright. Yeah, that's perfect. Okay, if I run the previous exercise, should also be good. So now if I do this, so it's there, the chroma. So it created a chroma SQLite. Okay, that's good. Now we're gonna create, yes, now I need to git ignore this. I also need to create the file number 16, which is going to be calculating cost. And in here I'm going to do this. So here I'm gonna do for this file add the missing imports. So let's continue. Okay, now okay, because I haven't saved, so you wasn't seeing it. So yeah, it's creating the documents and importing just tick token. I say it's alright because it was missing this library. and the documents. So now it can be self-contained and runnable. Now that's good. Now let's jump into this next exercise. This one is time to add those Netflix films and TV shows to your collection, provided with a list of documents, IDs, and text, which have been extracted from Netflix titles CSV using the following code. Okay. As an example of what information will be embedded, here is the first document from documents. All of the necessary functions and packages have been imported, and a persistent client has been created as an assigned to the client. Okay. So how to proceed in this case? So from the collection we do the here in the Chroma client we were doing the in this case it will be just create collection that the collection is called Netflix titles, the API token, documents append text. So here what I need to do is like take a hint. So I should just do collection dot add specify the documents and IDs. So I should do for collection in collections. No, for in this case it will be recreate your Netflix titles. Okay, but it's a switches generator. So it should be document in documents. I should do collection dot add, and in here I should add the document, I assume. And here first print the collection size and first 10 items. Collection dot size, I assume. And the first 10 documents are gonna be collection dot peak 10. Okay, maybe this is gonna fail. Let's see what it gets me. Explain the error. IDs and documents. So I should just do this and do IDs, it's equals comma, and documents, it's equal documents. The issue is that from where do I get the IDs? Sorry, here. Okay, the IDs. So I do this, and I should get both. So if I run, the only issue now would be like these two lines here. Explain the error. You should use the count method, okay? So it should be the number of documents, which is going to be the number of the documents that I had initially. How do you fix it? Okay. Now this is going to run, but I assume that now this peak 10 should be all right. Okay. So now if I should submit this, it should work. And it should be good. Okay, but this is gonna be not the 16, but this is gonna be the 17. Adding docs to DB. So now, based on this and also this, I need to refactor this file to use the Chroma client and generate the missing variables. So basically what I'm gonna do is like instead of doing this, I'm gonna use what I already have defined here in the Chroma client, and then I'm gonna add the missing variables, meaning the Netflix titles. It's gonna create a CSV file, it's gonna read it, and it's gonna create the IDs and the documents. That's nice. I'm gonna do it again because I think I didn't save it. And then we need to, 1 second, I'm checking my live stream if it's still available. So from Chrome, yeah, so it's getting their name, Netflix title CSV, and so it's doing this. It's calling the Netflix collection, and the rest is basically the same. So now this database is gonna be there saved. And because the database was already created, now I'm not gonna create a second one, but I'm just gonna add the documents there. So I got 10 tiles here with the show ID, title, and everything. Okay, so that's good. So now if I run this code, which is gonna be the Python 17, I assume, then I'm gonna be able to see now the results that I'm trying to print here, which is the number of documents and the first 10 documents of the collection. So let's wait until that. And now this is gonna be querying and updating dataset. Okay. Let's wait for a second. So I just got this response. Nice. So I'm getting the peak, the first 10 documents, and the number of documents. It's pretty nice. The IDs and the embeddings. And the documents by its own. So it's saving everything. It's saving the documents, the embeddings, and the IDs. on the metadata there was nothing, so it's okay. Cool. So let's jump right into the next into this slide.
We meet again. Let's continue our journey to learn about querying and updating our collection. Similar to what we did manually in the previous chapter, we'll build a semantic search application, but this time using a vector database. The approach is exactly the same. We have a query string, and we want to find similar titles in our collection. Previously, we had to embed the query string to get a query vector, which was used to find similar embeddings in the dataset. With Chroma, we'll let the collection do the embedding, so we can pass our query string directly, and Chroma will take care of creating the embedding and performing the search. First, we need to retrieve our collection, which we can do with client.getCollection, specifying the name of the collection to retrieve. Recall that when we created the collection, we specified the embedding function to use, and it's also really important to specify the same function when retrieving the collection. This way, Chroma will use the same embedding function to create the query vector. To query the collection, we call collection.query, passing our query string to query text.
This is super nice because you don't need to embed anymore. You just pass the query text there, and then the system, the ChromaDB, which is a vector database, just embeds that request, finds the closest similarities, like the function that we were having before, which is the find n closest, and then it returns you the answer.
Note that this parameter is plural, so even if we have a single query string, we pass a list. To specify how many items to retrieve, we can use the nResults parameter. Here's what's returned. It's not the simplest format, so let's break it down. First of all, it's a dictionary. It has entries for IDs, the IDs of the returned items, embeddings, documents, metadatas, and distances of the query results. The embeddings entry is empty, simply because Chroma doesn't return them by default. Aside from this, each of these entries has the same format. Let's look at IDs. IDs contain a list of lists. The reason for this is that the query method accepts a list of query text, meaning we could use multiple query texts. We just happened to use one. Therefore, the results follow the same structure. The first list is the results of the first query. If we had multiple query texts, we would get back as many lists.
Yeah.
As we can see, this is the same for each entry. They all contain a list of lists. Since we only used a single query text, we are only looking at the first list, the list for the first query text. In this list, we find a format similar to the parameters of the add method. The first ID corresponds to the first document, metadata, and distances. Next, let's see how to update a collection. Items in a collection can be updated with the update method. The syntax is similar to collection.add. In this example, we'll update the text for items ID1 and ID2. Once again, Chroma will take care of creating the embeddings using the collection's embedding function. Alternatively, if we are not sure the IDs are already present in the collection, use the upsert method. Upsert will add the IDs to the collection if they aren't present, and update them if they are, a combination of the update and add methods. Similarly, we can delete from a collection using the collection.delete method and specifying the IDs of the items to remove. Finally, if we want to completely empty the whole database, that means all collections and items, you can use client.reset. Time to put this into practice.
And I think this guy didn't emphasize this part, that if you do that, you will delete the whole database, so be careful. All right, so querying Netflix collection. Now that you have created a populated Netflix titles collection, it's time to query it. So the name, it should be this. I'm just gonna take a hint because I'm gonna get from the collection. I should do this is my Chroma client. This should be collection. It's equals to client and get collection. Embedding function is the OpenAI embedding function, which is already defined here. The API token is read in the system. The result, create a collection for fields about dogs. So I should do here the collection.query, and here in the query texts I need to send always an array, and in this array I'm gonna the first and only element for the moment is gonna be fields about dogs, and then the end results is going to be So I just need to run the code. And it's gonna return me this, and then I just submit the answer. Okay, that's good. Now we're gonna copy this into the, because we already had the movies, then now we just need to query from DB. So basically we do this in the 18, but because of the fact that we already have the chroma client create collection, we only need to do this, which is gonna be get collection, and we just need to specify in our case the get collection like this. It's going to be like this. This we're gonna pass it here, and this we're gonna just delete it. So the get collection is equals to collection query. So this should work too. The only thing is that in this chroma client, I think we have the create collection. We have, so we also need to define here just the get collection, and in this I'm gonna do the get collection embedded with and here is gonna be just get collection. So I'm gonna save it, and when I do the query from here, it's just gonna be the Netflix titles, because in the previous one when I added docs, yeah, the collection was also called Netflix titles, so I should already have data in there. So if I run the Python 18, Python 18, I should return 3, the more similar that is films about dogs. Let's wait for a second. Taking our card guardian. All right. That's good. Let's continue with the next one. Updating and deleting items from a collection. Okay, I'm gonna stop using this because it's not necessary. Unless we see another lecture there. Just because the documents have been stored in away in a vector, that doesn't mean that you can make changes to add to a collection or update existing items. Okay, so in this, you're provided with 2 Netflix titles storing a new data, and so this should be for film, and I'm gonna get the ID for film in new data, and it's going to do the same as here, which in this case is gonna be title, and this is gonna be for film and new data, and here I'm gonna do the collection, and I just need to, I'm gonna do the upsert. If the ID is already present, or I need the ID if it's not. Yeah, other than, so I'm gonna do the collection that delete, and I'm gonna do the same, the IDs here, but in this case I'm just gonna remove the S95 So it's gonna be this. So if I run the code, I don't know why I had this. No, I should be all right. Current title. Well, why not? Document. Sorry, it's not the. So I'll just run the code. So in this one, which is the query rename, so this will be update and delete from DB. And in this case, we're gonna do the same. We're gonna do this. First we get the collection, then we make all of the operations. In our case here we don't have this defined, so we need to put the new data, and this is gonna be new data. It's gonna be there, and then we are gonna update the S95, and we're gonna update the S1001 and S6884. But because of the fact that in our database, when we add the documents, we only had here, we don't have those ones, then we're just gonna add more to the database. So it's gonna be now not 10, but it's gonna be 12 elements. So if I run this, which is gonna be the Python 19, is going to give me now at the end 12 elements, and is gonna delete none of them because there is not the 95. So in this case, title cancel. Okay, now it returned me this document because this is the most similar, right, to the Cats and Dogs movie. Because in the previous one, in the Netflix titles, there was nothing about the dog as far as I understand. There was nothing. Now with this new update, with this new document that I inserted, I see that now there is like a cats and dog data. So therefore it worked good. Okay, that's good. Let's submit it. Let's go to the next one. Multiple queries and filtering. Okay, let's jump right into it.
Hi again. In this final lesson, we'll take a look at more advanced ways to use Chroma by performing multiple queries and filtering with metadata. Let's dive in. In the previous chapter, we used embeddings to make recommendations based on multiple data points. Let's do the same with the Netflix dataset and Chroma. We'll recommend movies related to other titles that a user has seen. Let's assume a user has seen Terrifier, which is a horror film, and Strawberry Shortcake Berry Bitty Adventures, a kids' TV show. It's an odd combination, but hopefully it will help differentiate the recommendations. Similarly to our previous implementation, we'll use the embedded text of the reference items as queries. First, we are using collection.get to retrieve both of our reference text. Notice that we are only extracting and storing the documents from these items in reference text. Since collection.query supports multiple query text, we can pass our reference text directly. We'll ask for 3 results. With multiple query text, we still get back a single dictionary. The difference is that we now get back multiple lists inside each entry's list. Looking at documents, for instance, we see a first list that matches our horror movie and a second list that seems to match the children's title. Even though we asked for 3 results, we're getting 6, 3 for each query text. Notice how the titles we used in the query were most highly recommended, which makes sense as they are the most similar to the query. These could be removed in post-processing by extracting the documents from the documents key and filtering out documents that are also in the reference text. Another great way of filtering results is by utilizing metadata. So far, we've only worked with the IDs and documents from the Netflix titles CSV. but additional information like the type, whether the title is a film or a TV show, and release year is also available. This data could be very useful if, for example, we only wanted to recommend films released recently. We've edited the code to load the CSV by creating a list to store the metadata and populating it with the type and release year from each row of the file, stored together in a dictionary. Like before, we also create a list of IDs so we can add the metadata to the existing items. We can
wait, it's going too fast. So we get the IDs and the metadata, and in this case we add one. In this case we're just gonna add one or two metadata, which is array, which is gonna be, we're gonna add the dictionary there, which is gonna be type and the release year.
So we can add the metadata to the existing items. We can update the items with their metadata using the update method, this time specifying the metadata argument. We can now use metadata to filter our query. We are going to make the same.
Because here in this update, here it was like the update, we could do the upsert with the documents, and now we can also pass the metadata. Okay.
Search as before, but we'll include a where clause to indicate we only want to retrieve items where the type metadata is movie. The where filter we use.
Aha. So this is like a bit more like exact, where the type is movie.
Okay. Metadata.
So where is gonna use the metadata then?
Is movie. The where filter we used here is actually a shortcut to mean equals, which we can define explicitly using another dictionary with the $EQ key. There are a few operators we can use to
like in Mongo
support different comparisons, including greater, less than, and not equal to. Finally, where filters can be combined with logical operators. In our case, we want titles of type movie and released after a certain year. To do this, we combined two where filters with an AND operator, type equals movie and release year greater than 2020. To filter for results that meet at least one condition, we can use OR instead of AND. There we have it. Our recommendations now only include movies released after 2020. And now it's your turn.
It's pretty good. Let's jump right into it. So in many cases, you will want to query a vector database using multiple query texts. Recall that these query texts are embedded using the same embedding function as when the documents were added. In this case, you will use the documents and the two IDs in the Netflix titles. So in this case, what we are going to do is gonna retrieve documents from the reference IDs. So from the collection, we are gonna do the query, and then we're gonna pass the, I think in the query from DB, we can pass directly the IDs, I assume. And here I'm gonna put the reference IDs. Okay, and here I'm gonna get the documents, which is gonna be like this. And then here in the result, I'm gonna get the reference texts. And no, in this case, I'm gonna do again a query, but this is gonna be now the query texts, and in this case, this is going to be the reference texts. And then here I'm gonna this is gonna be 3. It's gonna be numbers result. So it's gonna return 6 because it's 3 for the first ID and 2 and 3 for the second ID. So let's run this code. Whoa. What it says this. So this is just get then. This will correctly retrieve documents for the given IDs. So this is not correct. That's why it was failing. Okay. So now it worked. Now it's good. Now let's do the 20, which is going to be multiple text query. All right, so in this case, we are gonna do until just here. We are going to do this. In our case, because we only have S1 and we don't have too many data, we're just gonna do S1 and S2. We already got the from Chroma client. So we just need to do the get collection, and this is gonna call the next list titles. Then our references is gonna be this. It's gonna get the 1 and 2, and then we're gonna query with the reference text, and then we're gonna see the documents. Probably it's gonna return us the S1 and S2 because this is the more similar, of course. Let's just run it anyway. So it will be Python 20 multiple text queries. Let's save it. So in this case, in our here we have Dick and Johnson and Blood and Water. So basically these two should be the first who are shown here in the Python 20. But let's continue to the other one. Just give me 1 second, because I just want to make sure that, yeah. So you see here, Dick and Johnson is dead. So this is the first one, and then the second one, which is Blood and here we have one array. It's blood and water. Yeah, so it's there. So of course, because this is the most similar and we didn't exclude that from the query, then that's why we got that. Okay, now filtering using metadata. Having metadata available to use in the database can unlock the ability to more easily filter results based on additional conditions. Imagine that the firm recommended you have been creating could access the user set preferences and use those to further filter results. Okay, so now we're adding to the another thing. Okay, so now is the IDs, the metadatas, documents, create results from the collection user references. Filter the results for title with a G. Okay, so so here in the query, we're gonna it's gonna be query texts, and it's going to be reference text. In this case, I'm gonna get end results. I just need to get 2, but because there is 2 searches, it's gonna be 2 references. It's gonna be 4. Then in here, it should be the where for titles with a G rating. So released, also released, and this should be the and in here it should be the rating. and this is going to be equals to just in case here is that this and this and this. The rating should be G, and in the other one, which is the release year, should be greater than, and then here we can put the year 2019, and yeah, that should be pretty much. That's an extra logo. Okay, let's just copy all of this, okay? Because I think it updated the token on the screen. Okay, now let's do this. Let's run the code. Okay, so far it was none. Okay, let's submit, because maybe it's gonna show me the error here. So what is wrong in here? But I'm just gonna take a hint for it, because yeah, it's good, but maybe there is nothing in the documents. That's why. But it worked anyway. So let's just do, and this is called query with metadata, and this is gonna be the number 21, and in here I get this, and well, the collections is there. Yeah, and this is gonna make this query. And also here is gonna return nothing, because we, in our, as you may see, we didn't put any metadata there. So let's continue. Awesome, so we finished the embeddings. We started yesterday afternoon and we will finish today afternoon. Almost one day.
Congratulations on making it to the end of the course. Let's recap what you've learned and finish with some resources to continue your learning journey. In Chapter 1, you learned that embeddings are vector, or numerical representations of text that capture its semantic meaning. You used OpenAI's embedding model to create these vector representations and computed the cosine distance to compare the similarity between text. This unlocked applications like semantic search and recommendation engines that could relate text by their semantic meaning. In Chapter 2, you began using the OpenAI embedding model to enable real-world use case, including semantic search and recommendation engines. You also saw how embeddings can be used for classification tasks, including sentiment analysis and categorization. Finally, in Chapter 3, you took a big step toward creating a production system by learning about vector databases. You learned how to use Chroma to embed, store, update, and query vectors in a more reproducible and efficient way. So what's next? Luckily, DataCamp has a ton of resources for you to continue your journey. For enterprise companies with more funds or startups looking to move quickly to capture demand, a cloud-based managed vector database could be a good option. Two of the most popular are Pinecone and Weaviate, and you can learn about both right here on DataCamp. For many AI applications, including chatbots, embeddings and vector databases are only a part of a larger system, which may also include large language models or LLMs. LangChain is a great framework to tie all of these pieces together under a single, unified syntax. So check out these resources if you're interested in learning more. Congratulations again. Best of luck on the rest of your learning journey.
That's awesome, guys. So we
Congratulations on making it to the end of the course. Let's recap what you've learned and finish with some resources to continue your learning journey. In Chapter 1, you learned that embeddings are vector, or numerical representations.
Now we finish this. Now we are just going to now we're going to commit this embeddings part 2, and this is gonna be the 14th. which is the day of today. And now let's push this code so everyone can access to it. And that's perfect, guys. I think we are almost 62%. It's just remaining 3 courses: building AI applications with Pinecone, software engineering principles, and developing LLM applications with LangChain. But first of all, I think what we are going to do tomorrow is going to be the topic analysis of Cloud reviews with embeddings, because it's going to be really important, because we need to put these projects into GitHub. So far it's been great. Thank you very much for being in this stream. I hope you liked it. So you can have the whole code into GitHub.